Hi, good day everyone. I am Novi and today I am going to show you how to graph sine and cosine functions with changes in the amplitude, period, phase shifts, and vertical shifts. But of course, for us to understand the topic better, we have to be familiar first with our unit circle and how it is translated into the x and y axis or the Cartesian coordinate plane. Now, we know that cosine theta is equal to x over r, and sine theta is equal to y over r. Now, since this is a unit circle, that means our radius from this point to this point is equal to 1, which means the value of our r is 1. Now, substituting the value to these two equations, that will give us cosine theta equals x and sine theta equals y, which means that the x coordinates here around our unit circle are the values of our cosine theta, and the y coordinates are the values of our sine theta. Okay? Now, please also remember that in trigonometric functions, what we are putting in are angle measures. So, the coordinates here of our x-axis are the values of our theta, because the x-axis is our domain. And as far as trigonometric functions is concerned, what we're actually trying to get are the ratios of the sides of the triangle using the angle measures. Okay? Now, let's start plotting these points here. We'll begin with the sine functions, which is y equals sine x. Again, let's begin plotting using the y coordinates, and let's see how the graph of our y equals sine x function looks like. Okay. Now, take a look at this point. At theta equals 0, the value of our sine is 0. So that's here, in our origin. At pi over 6, the value of our sine is y 1/2, which is equal to 0.5. So that's pi over 6, 1/2. It's here. Okay? At pi over 3, the value of our y is square root of 3 over 2, which is, if you use your calculator, that is about or approximately 0.87. So that's somewhere here. Okay. Now you might notice that I did not include pi over 4 because if I include this one, that's going to change the interval. So I will be only using pi over 6, pi over 3, 1/2, so on and so forth. So we will not be including the 45 degrees angle. Okay? Now continuing, at pi over 2, the value of our sine is equal to 1. So that's here. Okay. Now let's start from there and let's try to observe the relationship of our x and y. Now, as you can see, from this point here to this point, our x decreases while our y increases. And that continues, okay, until we reach 90 degrees. Okay? Again, our x decreases while our y increases until we reach 90 degrees or at pi over 2. Now, at pi over 2, now, if there is no change in the amplitude at all, there is no change in the amplitude, that means that we are only considering our basic function. This point here in our y becomes the maximum, and our x becomes the minimum. Okay? Now, if we continue to rotate, okay, as you can see, our y decreases while our x, though negative in value since it is to the left side of our y-axis, our x becomes the maximum, again, though negative in value. And that continues until we reach the left side of our x-axis or the 180 degrees. Okay? Again, the y decreases and our x increases, though negative in value. Now, if we continue to increase the angle generated to 270 degrees and eventually to 360 degrees, the pattern just keeps on repeating. Okay? Now, let's continue what we have started earlier. At 2 pi over 3, our sine is square root of 3 over 2, so that's 0.87. At 5 pi over 6, y is 1/2, or 0.5 pi over 6, that's here. At pi, sine is 0. Now, at 7 pi over 6, our sign is negative 1/2. So we just get the same value though, the same pattern, but in this case, we already have negative value since the value of our y is already below the x-axis. Okay, so at 7 pi over 6, we got negative 1/2, so that's negative 0.5. At 4 pi over 3, we have negative square root of 3 over 2, or negative 0.87. And then at 3 pi over 2, quadrantal angle, we have negative 1. And then at 5 pi over 3, our sign is negative square root of 3 over 2. And then at 11 pi over 6, we have negative 0.5. And at 2 pi, we have 0. So if I'm going to connect these dots, okay, we have this graph here. Okay? Now, how about if I'm going to use the angle measures in a clockwise direction, which means this point here becomes our negative pi over 6, this one becomes the negative pi over 3, so on and so forth. So let's just plot our points. So at pi, negative pi over 6, it's going to be negative 1/2. Okay, that's here. At negative pi over 3, negative square root of 3 over 2, or negative 0.87. At negative pi over 2, that's negative 1. And then negative 0.87, negative 0.5, 0.5. Okay, let me erase this one. Okay, and then 0.87, 1, 0.87, 0.5, and then 0. So connecting these dots. Okay, so this is how our sine graph looks like. As you can see, now it's like a wave, a smooth wave. It can be a light wave or a sound wave or what have you. Okay, now you might notice that if we are to rotate, or if we rotate this graph 180 degrees, we will still get the same exact picture. Now, functions with graphs like this are actually called as odd functions. Okay, now this time, let's see how the graph of our cosine functions look like. Okay, so we have y equals cosine x. Now again, we are still plugging the values of our domain, but this time what we are getting are the x coordinates, since this is a cosine function. Okay, so at 0 degrees, our cosine theta is equal to 1, so that's here. At pi over 6, we have square root of 3 over 2, so 0.87. At pi over 3, we have 1/2, 0.5. At pi over 2, that is 0. At 2 pi over 3, negative 1/2, that's negative 0.5. At pi over 6, we have negative 0.87. And at pi, we have negative 1. Continuing that, we have 7 pi over 6. It's square root of negative square root of 3 over 2, or negative 0.87. At 4 pi over 3, negative 1/2. At 3 pi over 2, it's 0. And positive 1/2, 0.87, and then 1. Connecting these dots, we have this graph. Okay? Now how about if we take the angles in the clockwise direction? So again, this one we have square root of 3 over 2, or 0.87, positive 1/2, 0, negative 1/2, 0.87, negative 0.87, negative 1, negative 0.87, at negative 4 pi over 3, that is negative 0.5, 0, positive 0.5, positive 0.87, and then we have 1. Okay? Connecting this. Okay. Connecting this point. We have this graph. So this one here, which is also a smooth wave. And again, it can be a light wave or a sound wave or any forms of wave. Okay, now as you can see, you might notice that to the right of our y-axis and to the left of it, they look the same, right? Now functions like this, okay, functions that are symmetrical along the y-axis, we call those as even function.